A while back, a friend of mine asked me to make 8 remotely controlled RGB lights to set the pace of the athletes at a running track. It took actually a while, but here is the final result. And here's how I made them. Here's the parts list. We have a power RGB and white LED with a heatsink, 3 base resistor and 3 BJT for controlling them, a switching power supply and a toggle switch, a lithium-ion battery with a charging and protection circuit, an RF24 radio transceiver with a linear regulator, an Arduino Nano as a microcontroller, and finally a push button for turning on the white light as a service light. The schematic is straightforward. We have the battery with its regulator, the power supplies, the Arduino, radio, RGB light, and the driver circuit. Then it starts the soldering part. First by removing the leads, which were pre-soldered on the nRF24 radio, and also from the linear regulator to 3.3 volt, which is necessary for the radio, which also will be soldered very close to the radio to avoid line interference. Then I soldered the Arduino Nano close to it, and on top of it the switching regulator power supply. Then I start soldering wires to the charging and protection board for the lithium-ion battery, and I attached it to the main board, basically to the switching regulator, and added some toggle switch to toggle between on and off, and the push button to turn on the white LED even when the whole thing is off, to connect directly to the battery the white LED. Then I connected the SPI port of the radio to the Arduino Nano, and now I start soldering the wires to the LED, which is actually 4 separated LED, each one with an anode and a cathode. The anode of the white LED is connected directly to the push button, and the other one are connected to the driver board, which is the next thing to build. So 3 BJT transistor with a base resistor and a power resistor. The white, blue and green share the resistor, and then there is another one for the red LED, because the red LED uses a PNP transistor to alternate the on time and off time with the PWM signal from the Arduino to reduce the power. Then I connect the driver board to the Arduino and assemble the wires for the LEDs. And finally, I connected the battery, isolated with some tape, and test the LEDs. Then I 3D printed an enclosure with some holes for the switches, the push button and the toggle switch, and a cap with a hole for the antenna. Then I assembled everything together with some glue, and here's the result. Now it comes the programming part. I wrote a sketch with the Arduino IDE, which contains basically the logic for the web server, the access point, and all the communication protocol between the master board and the peripheral radios. So I made up a code made of simple alphanumeric symbols to communicate the color, the duration, and everything. Then I started designing web interface, which is basically an HTML page with all the controls integrated. And that's it.
So here we are, 7 slaves and 1 master radio. These ones are controlled by an Arduino Nano, and this one is an ESP32. So all of these has this little push button which activates the white LED as a service light, and a toggle switch to turn them on. As soon as you turn them on, they start blinking green, meaning that the battery is on an acceptable level. Otherwise they will blink red, meaning that the battery is running out. As soon as I turn on this master light, which can be turned on with the push button switch, they all synchronize in a blinking blue light. Now I can control it with the touch sensors, so blue, green and red, and I can also combine them, for example, to make yellow, green and red. Or I can toggle the toggle switch and activate in the white light, warm white. And finally I can use this web interface, on which I will focus right now. And this is reachable by connecting to the access point created by the radio on one, as you can see in the top, 192.16841. And if you reconnect to the Wi-Fi access point created by this, you can refresh this page and control, as before, the colors: red, green, blue, K for black, so to turn them off. Or you can use one of the presets. For example, this one is a alternating red light, blinking red. And you can also create one of these sequences by adding a row, choose a color, a blink type, and the duration, minutes or seconds. Add another row, another color, another blink, and then you can either send it directly to the master radio or give it a name and save in one of the available spaces. Then down here you can see the current color selected, for example magenta, and the phone to which the master radio is connected to, the touch control, either on or off, and the battery status of all the radios. Actually I have to charge up the last one I just finished without charging. You can disable the touch buttons, and you can try to reconnect all the non-connected radios. Down here there are some advanced controls for sending directly codes to the radio. And that's it. Thank you.